yeah, really excited for Justin to come give another talk. He's an engineer at Klaviyo and loves using Python for work and personal projects. And you can check out his previous talk on our YouTube channel about DuckDB earlier in the year. That was a good one. And I'm really excited for him to give this talk on using UV. So welcome, Justin.
All right, so outline of what we'll be discussing. I'll be talking about what is UV, just kind of at a high level, and a little bit about the company behind it. Well, I guess let me back up and say, if this wasn't caught, not affiliated with Astral, the company developing it, or UV, the project. So I'll be talking about what it is and a bit about the company. I'll talk about Python development at kind of a high level of like just the steps involved, both for smaller projects and kind of steps involved in production for larger projects, for just to keep it beginner friendly for those that aren't necessarily seasoned Python veterans, to make sure everyone's on the same page there. I'll be talking about how to go about that with the typical packages. So your pip, virtual environments, all those kinds of things. I'll talk about how it's done the UV way with their new workflow. I'll show some examples in code. So working on my computer here, and then maybe finish off with just some points about where they're looking at going with the project and potential future of Python development, and some deeper dive resources at the very end as well. All right, so what is UV? This is from their documentation. They call it an extremely fast Python package and project manager written in Rust. It's fast because it's written in Rust, but also some additional enhancements they do with the package. So there's some interesting resources I'll link at the end that go into more detail. But just how fast, this is a benchmark they put out of how quickly UV resolves dependencies for the Transformers project, which is a massive project with all of its dependencies. So this is really just them flexing how quickly they can go through all of managing dependencies. So as you can see over poetry and PDM that they're comparing here, it's not just slightly faster, it's pretty significantly faster. It really has implications for what you can do differently with Python development when you have that much speed, when you don't have to worry as much about how long it takes to resolve dependencies and install those dependencies. It actually started as just a simple replacement for pip. Simple. It started as a faster pip. It was their goal, was to be able to drop in, replace pip, and increase the speed of package installation. It's now evolved to an end-to-end project manager, which can do Python installation. It can execute scripts, and just some more features coming in the future. And getting started with it, you can actually pip install it, which is kind of funny, but you can also curl install it. So it's its own tool that runs outside of Python. And the company behind it, like I mentioned before, their name is Astral. It's just their sign-on page. And they are a company working to make Python tooling outside of UV as well. So looking to really change the Python development process. They make UV, of course, but they also make Rough, which is a very fast Python linter. And they just took stewardship over this project, Python Build Standalone, which manages Python installations for a lot of projects. So that has some interesting ideas for them going forward. And I wanted to shout them out to give some reasons why you might not use UV, you know, if you're skeptical or just don't want to adopt brand new projects, because it is a relatively new project. It actually first came out February of this year, and they only released the end-to-end project management features in August of this year. So that's just to say, you know, they haven't had a ton of time to show where the project is going. It could change directions in certain ways, but it is used quite a bit already, and they are going in a good direction so far. And the company itself is VC-backed, so they may need profit at some point, so they may need to charge for tools like UV. You know, for those familiar, it could be a sort of Terraform situation where Terraform started charging for their product, which used to be open source, and then there's a fork called Open Tofu, which people have to maintain now. But just some things to look at, things to look out for. But why you should use UV, just things that are exciting about it. It's open source, so less risk of, you know, the profit motives potentially, and it already has wide adoption of 21 million monthly downloads this past month, and of course it's very fast, so good reasons to use it. But so that's UV at a high level. I'll get into some code shortly here, but first I wanted to talk a bit about the Python workflow of what does it mean to develop in Python. Because to start developing in Python, you need to download the correct Python version that meets the requirements for what you're developing. You need to create and manage virtual environments for you to install and run packages out of. You need to download packages and libraries. And you need to run your script, of course. And this is kind of a smaller scale project, what's enough to get going with Python. But if you're in production as well, you also need to manage dependencies at a more detailed level. You need to package your project and potentially use Python tools. And I call these out because as it stands, there's a lot of different tools that are used to do this today. So just to do these steps, there's all these different tools to do that with. And of course, there's ones here that aren't mentioned. So just for the simple development, you might use pyenv, you might use venv, venv, or virtual env. You might use pip or conda. To run your script, you might use Python, Python 3. I still get use the wrong one whenever I set up a new machine before I alias it. Same with pip and pip3. For production, I know I'm missing ones here, but pipenv, poetry, pdm, rye, poetry again, setup tools, just a ton of different ways to do the same things. And some of them are more full featured than others. Some are more convenient. Some work well with each other, but just lots of different options. And of course, you don't always have to use these tools every time you use Python, like pyenv, downloading the correct Python version. It's something I do every couple months whenever there's a new Python version, or when I realize my old laptop is still running Python 3.8 and it can't run certain packages anymore. So these aren't necessarily day-to-day frustrations, but it's just a lot to learn, especially when you're starting out with Python. The idea of UV is to do this all in one package. So it's to manage all these different steps. And really, once I click forward here, you'll see some drop off. They also, because of the speed and what they're able to do, you kind of lose the need to have to manage your Python versions and manage virtual environments, which can make it really simple to run Python projects. If you work with other languages as well, this is similar to other projects. The steps required to develop in it, it's very similar to the Rust language's cargo project, which has a very similar ethos here, and they are explicitly trying to recreate cargo for Python. So with all that, let's get into some code examples. I wanted to show workflows of using Python, running scripts with the traditional tools, with the typical tools, and then I'll show what the difference is with Python here, or excuse me, with UV here. Now, let me sit down on the microphone now that I have. Technical difficulties while I pull up. Okay, so I have a project here that's just a couple things in here. I have some data files, so some CSV files, and a Python script here. This is just a simple script, so just to show what we're working with here. This is just a simple data analysis script. So using a couple packages here, DuckDB, Streamlit, Pandas, and Plotly, it's just going to take in those CSV files, do some data processing, create some data visualizations, and it will show those data visualizations in Streamlit, which, if anyone's unfamiliar, is a data visualization web app to create interactive data graphics. Not super important what's in the code here because we're mostly showing how to work with the code, because UV makes it easier to run certain things. It won't write the script for you. That's what ChatGPT is for, I suppose. So go outside of the script here. So as it says up here on the slide, I'm going to use pip and virtual venv, excuse me. So it'll be pretty similar, pretty familiar to most folks here. So to run this with the typical tools, you need to create a virtual environment. So Python, call it pip venv, which takes a bit of time to load. And then you need to put your dependencies in here. So from that script, like I said, it was just pip installing DuckDB, Plotly, Streamlit, pandas. Oh, I didn't source this. I forgot to source my virtual environment. So virtual env, you need to source your virtual environment, and then you need to install your packages. So we rerun that command here. That will install the dependencies we need. And I wanted to show this live, also to show the speed difference. Like I mentioned earlier, UV is quite quick when doing this stuff. So even with this pretty simple project, it takes long enough for me to have time to explain this, which we'll see with UV later. This process is just a bit quicker. So now that we have those installed, we can run the script that I showed earlier with just Streamlabs. It is different. So Streamlit run script. And once I run this, it will open up the data visualization app. Running. Great, there we go. So there it was just creating the virtual environment, installing the packages, and then we're able to run the script as we see here. That's again, creating virtual environment, pip install, and I wanted to show pip freeze as well. So now that we have the project running, we know it works. Say we're wanting to share this project with people, we need to upload it to GitHub and be able to have coworkers or friends run the project. Now that we have the virtual environment with the packages installed, we can do pip freeze, which will create a requirements.txt file, which has the information on what packages we just installed to run this app. And requirements.txt is not a pretty file because there's lots of different dependencies. You know, you saw me only install 4 packages, I think it was, but it has all these dependencies of the packages I installed. So it's a lot to be able to parse this out. And if there's version changes, there's some manual work involved, or you might have to go through and manually uninstall the dependencies of the packages you installed. It's hard to know which ones, which packages depend on which ones in there, which there's even that package, which all it does is just list which packages come from which libraries. So Plotly also installed packaging, Tenacity, Streamlit also installed Altair, which installed these even further down dependencies. Just a way to visualize that. So can be hard to parse out the requirements text file, which UV also can address in certain ways. So that's kind of the typical way there. Let's look at it with UV. So we're still in the virtual environment here, so still using the same thing I just created. Since UV was released originally as a drop-in pip replacement, it works out of the box with simple pip commands. So you can do pip commands prefaced with UV, and it will function the same. So if we were to do, let's see here. So we could recreate this virtual environment using UV pip, which will give us the speed of UV without having to learn the new commands. So you can actually deactivate the virtual environment. I'm going to remove the virtual environment I just created. So that is just deleting the dependencies here. Dun. So I'm creating a new virtual environment, which I'll use UV on to show kind of the speed difference there. So we'll do source, UV, pip, V. So now I'm in the new virtual environment with nothing installed. And now that I have this requirements file, I can install the requirements from that, or I could reinstall it the way I did before with pip install pandas, DuckDB, Plotly. But instead, I'll do it with the requirements file. So you can do uv pip install our requirements.txt. So doing this again, it's using that requirements file and just doing the same installation we saw before. And doing that, you get the speed upgrade again without having to learn the new tool. So that's where the drop-in pip replacement comes from. But there is also the UV way to do it. So that requires, or that depends on using some of the old workflows of still using requirements files and really just not changing the way it's being developed. But UV is also sorry, trying to do too many things at once. UV is also trying to streamline how you manage the different things there. So as I showed with the requirements file, it's a little clunky to be able to work with. Instead, they're using different ways of managing dependencies. So we can remove requirements here just to make sure, just to clean up our folder here so it's still easy enough to look in. Clear that out. And instead, what we'll do is UV init. And what this does is initialize a UV project, which gives us some new files here. There's Python version, which just specifies which version of Python we're using. There is a hello.py script, which is just a sample script that comes whenever you initialize a product, which just says hello from UV demo. Oops. It also makes it README, but the main difference is this pyproject.toml. Looks a little bit different than a requirements.txt file, but it's just a more robust way of doing the same thing. So if we look inside pyproject.toml, it just has some project descriptions here. So it takes the name from the folder. You can give your project a description, specify the README, specify the Python version, and if you want to version your project. But this dependencies is where we'll work with the requirements of our project rather than the requirements.txt file. So UV allows for a different way of adding dependencies here. Instead of doing pip install, you add them to the project. So UV add, and we'll do the same libraries we added before, which is pandas, DuckDB, Plotly, and Streamlit. And if we go back in PyProject, we'll see those added to the dependencies here. So it just keeps it much cleaner without all those extra dependencies in the project there, while still managing those sub-dependencies underneath. So now that we've done that, now we have, and once you do that, it also creates a virtual environment. So it does that managing for you. You don't have to do the Python -m venv, which this is what is used to create virtual environments. Instead of doing this yourself, UV kind of manages all that smartly without having to keep uninstalling and reinstalling it for new machines. Especially, that is a big advantage of how fast UV is. It's easy enough to just delete that .venv file and recreate it because it'll be quick enough. So now that we have all that installed, it should already have the packages in here. We can just UV run, and then the same command we used before to run the data app. And while that's running, this isn't really part of the UV thing. This is just the app spinning up. So, so you can see it's just a different set of commands that kind of simplify things in terms of using UV add and remove to bring in those dependencies instead of pip install. I haven't shown off UV sync here. UV run to run the commands to run the scripts themselves. So that's running the Streamlit command. So we have that. Now, so I show this off as me adding the dependencies here. So adding it this way, which adds them directly to the pyproject.toml. But let's go the other way of pretend I had just pulled the PyProject.toml, I pulled the dependencies. I haven't installed the project. Excuse me, I haven't installed the sorry, I'm tripping over myself. I haven't installed the libraries to run the app. I've just done a git clone to pull the project in here. Instead of doing pip install pip install, oh shoot, pip install /r requirements.txt, UV has an additional command that kind of functions in the same way, but again, just taking advantage of the UV way of doing it is UV sync. So much like how pip install /r requirements.txt will install your requirements from that requirements file, UV sync will install requirements from the pyproject.toml. So it's just a different way of managing requirements between computers, between folders, that kind of thing. And I'll note a bit of the difference between requirements.txt and pyproject.toml again. Again, if I go in here, so again, functionally achieving the same thing. Pyproject.toml is just a new standard in Python. Which has been kind of becoming more popular as more projects are adopting it. So achieving much the same thing, but just kind of gaining adoption. Yeah, still not as widely used, but UV makes it easy to kind of make the switch over to that, where it can pull your requirements file into the PyProject file, make that transition a little bit more seamless. Okay, so a couple things to note here. So now that I've run that here, you can see, UV add is a way to add files. UV run is a way to run the files. Another kind of subtlety that might have been lost in there as well is this pyproject.toml also specifies the Python version in here. Since UV also acts as a Python installer, you don't necessarily need to install Python yourself. UV will manage that for you and install that without having to go out and get it. So that means, especially for getting started in Python, if you're just starting out and just learning the Python development workflow, it's just one less thing to manage. Instead, what you can do is git clone a Python project, do UV run, and as long as this pyproject.toml file has the dependencies and the Python version is valid, it will run without having to have those additional tools in there. So it could be a big unlock for people getting started with Python. Let's go back to this here for a moment. So again, just notes on UV sync as well. As I said, it's syncing your requirements file and your environment, similar to this pip install. But with this being a drop-in where you can interface requirements.txt files with UV projects, it also makes it easy to drop into existing, say, CI/CD workflows or other workflows that are already using pip. So this is a note for those using Python more day-to-day. Can be good for professional development as well. Oops. And one thing I hadn't showed off that I just wanted to show off for people. Shoot, keeps coming back to the other screen. Wanted to show off that UV does as well. It's just this UV tool. If you've used other Python tools like pipx to run tools, it is a replacement for that. So say say you're working in a project that needs like linters in that, you can use UV tool just as you use pipx to pipx run linters. So like pipx run rough or UV tool rough would work. Or if you're just messing with messing with some tools, you can also use it to run UV tool run, excuse me. Shoot. The text. There we go. Sorry. So you can also use UV to easily run tools where it also uses the speed of UV to be able to download and execute commands in those tools. Kause is a fun one to get started on. So that's kind of the like getting started of UV, of using it in place of pip and also using it with requirements files. So dropping it into those workflows, either using UV sync as shown here, or using UV pip, which functions functionally the same, just with that UV prefix. But UV is in active development. They have docs and all sorts of resources, but I think the best place to kind of track what they're doing is in their GitHub issues page, where they show just kind of different things they're working on. One thing interesting coming out is this UV workspaces. Might be hard to see on the screen. But UV workspaces, which is for mono repos and making it easier to work in mono repos. So to see the features that they're adding there, they have a lot there. But also just deeper dive resources for those trying to get more into you. I thought I put the docs on this page. Sorry, sorry, I'm jumping around on this. But there's also lots of good videos out there of just plenty of YouTube channels that are putting out new ways to use UV. This is the creator of UV, or sorry, not creator of UV, creator of Astral, which makes UV, talking about UV more in depth of some of the challenges they overcame to really make speed improvements beyond just writing it in Rust, more about dependency resolving and that kind of thing. He also did a talk here on Rough, which is another project that they work on, but it gets into some interesting details of, again, how they make it as fast as they do beyond just the language it's written in. But yes, if anyone's interested in these resources, feel free to reach out. I meant to put the UV docs in here so I could go to them. Because they also have docs on more involved uses of it. I didn't get into all sorts of, or some of their more advanced features of locking environments for more production projects, but some things to dive into there. Yeah, any questions? Yeah.
All right. Yeah, thanks very much for doing this talk. I was wondering if you had any idea what exactly they're doing to make the package download so much faster. Because I always thought that most of that pip install time was just pulling it over the network, but it clearly looks like it's something else. Do you have any ideas what
I
that
think
is?
it's a couple different things. I think there is like the speed improvement, the meme of it's written in Rust.
Yeah.
So it is just quick. I think it's interesting they get into, or the Astral founder here gets into how they went about dependency resolving, because I think that's where most of the time actually comes from, where it's when you're resolving dependencies of like Streamlit, like you saw, where there's a bunch of sub dependencies that go multiple layers down. It's just very inefficient the way it's done in pip and other packages.
Oh, cool. Thank you very much.
Mm-hmm.
Hi. Quick question. Hey, Brian, thank you very much for the contribution. I have a question. How does it compare against Mamba in terms of speed?
Against what was that? Sorry.
Mamba is the spin-off from Anaconda.
From Conda and like the data
Mamba,
science stuff,
Mamba.
yeah.
I've not seen Mamba itself. I've seen benchmarks against Conda and pip, similar to what is up here. I think I would expect similar speed improvements over this, but like I said, I'm not familiar with Mamba if that is a like attempting to be a faster.
I think that's like written in, it's like a C++ version of Conda. Is that right, Antonio? Something like that?
It's a rewriting of Conda in C++, but it leverages a SAT solver called libsat solver that comes from OpenSUSE. Yes, written in C++. That's right.
Yeah, I'm not not familiar with that one, so I can't speak to it specifically. Yeah, I'm not sure of any direct comparisons.
I saw Evan put in the chat. He was asking if cow says and was installed on the fly.
It is installed on the fly, yes. When you use the UV tool commands, it does pull those down as you need them. I think there is a what is it? UV tool install, is it? Let's see. I think yes, it is. So you can install it and then you just have it.
It is so cool that how instantaneous it is, right?
I missed something there. Does that work? There we go. Now it's installed. So once you run UV tool install, then it's on your machine. But otherwise, every time you do just UV tool cause, it does pull it down every time. But yes, it is quite instantaneous.
Hi, Dan.
Hey,
Hey,
Ben.
hi. Just a question for uh, use with NeoVim. I noticed that you were using NeoVim as well. I was just wondering, do you activate your virtual environment before you start editing Python text, or do you have some sort of a plugin within NeoVim that actually you can search for virtual environments in? Thank you.
I guess. I always run it in terminal, I suppose. I'm not a true blue NeoVim user in that I've fully fleshed out my development environment. I use it for the text editing, but I don't run my scripts from inside if there is a NeoVim IDE that can run that. But usually I'm running it in terminal. So here I don't have to activate the virtual environments with the UV way, but whenever I'm using pip in the terminal, then I do activate the virtual environments.
Thanks,
Okay,
Ben.
thank you.
Evan was also asking if we can use pip freeze to see dependencies using UV.
You can. So that will, let's see, does that do that from the virtual environment? I believe the pip commands, all of them will work as normal. Requirements.txt when you add UV to the front of them. So I believe this will pull the packages from your environment, in this case .venv, and freeze them to the requirements.txt file. So once I do that, now we have this new requirements.txt file, and let's see. Yes, so it does create it just the same way as it did with just pip freeze. And it even created that quite fast.
Any other questions, anyone? All right.